Okay, we'll discuss about module 4, that is design of tension members. Okay, anyhow, here we'll get 20 marks in the module also. 15 marks problem plus 5 marks theory. All the theory questions are important. I given yesterday's I given in the group, I shared in the group all the theory questions. Total 28 questions are there. These are the important questions I gave. Okay, anyhow, we'll start. A single angle 100 into 100 into 8 mm, that is angle, right, 100 into 100 into 8 mm, connected to a gusset plate with ends with 20 mm diameter bolts, that is 20 mm diameter bolts with the connection length of 200 mm. And this actually this diagram is given in the question, right? This diagram, LC is 200 mm. Then what is LC? LC is nothing but bolt to bolt dimension, right? Last bolt to first bolt, that is 200 mm. And the values of your pitch and edge values, right? Pitch is 550 here, and edge is nothing but this edge and this edge, that is 40 mm. And total is how we got 100 mm, because a given 100 into 100 into 8 mm, that is total is 100 mm, and the thickness is 8 mm, right? Bottom, the line is given and the leg is the bottom, that is 100. This is the bolted connection showing black and white, that is black shaded, that is bolted connections. Okay, our given datas: ISA 100 into 108 20 mm dia bolts, that is D is 20 and D naught is 22, LC is 200. Okay, first 3 steps are there: gross section yielding, next section, and block shear, right? These 3 steps also we need page number 32 first, right? For that we have to go for page number 32 for the formula of gross section yielding, right? Here this formula, page number 32, 6.2, that shows the class number here. Page number 32, 6.2, that is class number, that is TD is equal to AGFY by gamma m naught, that is first formula for the first step, where AG and FY values, AG values we have to get from the steel table, right? From the steel table, AG values are there, page number 4, for 100 into 108 mm, right? I shown in the previous problem also. Again, if you want doubt is there, means you can contact me. IS 109, there will be a thickness given like this, 6, 8, 10. So 8 mm, along that you will get area in the second column, that is 15.39 centimeter square, or 1539 mm square. We need in mm square. 1539 into Fy is 250, then gamma m naught is 1.1. You will get in terms of Newton, you have to convert into kilonewton by multiplying, divide by 1000. Okay. Second step is net section rupture, page number 33 of the 6.3.3 class number, right? You go to the page number 33 now. Okay, here, okay, to one page is came again itself. Okay, whatever this page number 33, I'll show you here. Page number 33, the value is here, the formula is here. TD 6.3.3 single angles, the TDN is equal to 0.9 ANCFU by root 3 ml and beta AGOFY by root 3 gamma m naught. For to find beta value, the formula is here, right? Simple formula, W by T, Fy by Fu, Bs by Lc, and this should be less than this value, should be greater than 0.7. This is the beta value, then you have to substitute beta value here, then you have to find out TDN. That is the second step. Okay, we'll show here. Page number 33, we got this TDN formula. To find out ANC, right? This is a formula. ANC is equal to L minus D naught minus 3 by 2 into T. This formula is not there in the code book. You have to remember. L is the total length, right? L is nothing but L and T, right? We need, right? L is nothing but the length of this one, that is 100 into 100 into 8, and 8 is the thickness, that is T value, right? So here 100 into here 100 minus L naught, that D naught given in the question, diameter is 20 mm, D naught is 22 in the initial stages we did, and then 8 by 2, right? Minus 8 by 2 minus T by 2, that is into 8, that is 8 itself, T value. So you'll get ANC value, then you have to find out AGO value here, But AGO value is same here, but you have to go L1 minus T by 2 into T. So whatever the angle is given, that is 100 into 100 into 8. So L1 is nothing but second leg. If it is 100 into 100 same, then L1 is also 100. So 100 minus T is 8 by 2 into 8. Here one different is there. There is D naught is not there here, right? That is the AGO. You'll get 768 mm square. Okay, now we got it. Now for the beta, whatever I sold in the page number 33, we got beta values here, right? This is the beta formula. Here we need one is W value, that is W is length of the angle, that is I told 100 mm, same as here L value. Then W by T is always 8 mm. Then Fy is 250, Fu is 410 given in the question. Then we need BS, LC is 200 given in the question. Initially we did. Now we need BS values. BS is the formula W plus W1 minus T. This for the BS, you no need to remember that formula is given in the code book. Wherever page number 33 is this given, the BS is given here, W plus W1 minus T. Whatever the W value, this is W, that is 100 mm. And W1, what is W1 till the bolt? What is this value? That is W1. How to find out W1? I'll tell. Minus T. This formula is given in the right. Okay, this formula is given in the code book. Now BS is W plus W1 minus T. What is W1? That is 60. How we got W1 as 60? For that, what you have to do? You have to go with the problem now. Initial diagram they given, right? So in the diagram itself they mentioned here. See here in the diagram itself they mention up to here bolt connection, that is 60 mm. So wait. Anyhow, this is 60 and this is 40 from the bottom leg, because the leg is in the bottom. From here how much? That is 60 mm, that is W1, remember. So W1 we got it. We'll substitute that W1 values here, right? You got BS values now. BS values 100 plus 60 minus 8 is thickness. You got WS values. Then LC is 200, Fu is 410. Then beta value is calculated 1.4 minus 0.06 into W by T, that is 100 by T into Fy by Fu 250 by 410 into BS by LC 150 by 200. We got value as how much? 0.96. Should be less than this value, right? That is here Fu gamma m naught by Fy gamma ml. Fu is 400 into 1.1 divided by 250 into 1.25, that is gamma ml is 1.25, and should be greater than 0.7. We got 0.96, less than 1.4 and 0.7. So beta value is correct. Now here this beta value I have to substitute in the formula of TDN formula. Here initially we got it here. Here we need all the values, right? ANC and AG also we calculated. Now we have to substitute 0.9 into 592, that is ANC value, then Fu, then 1.25 is gamma ml, then 0.96 beta value into 768 is AGO value, then 250 value, 250 is nothing but Fy, and 1.1 is gamma m naught. This value you have to substitute, then you will get in terms of Newton, you have to convert into kilonewton. Third step is block shear. This formula is there in the page number 33 on the other side. Here you can see page number 33, this is TDN formula we just needed, and then here block shear formulas. There will be TB1 and TB2. Two formulas are there. Two formulas you have to note down, right? Both formula you have to note down. Here AVG, ATN, AVN, ATG. These four unknowns we have to find out. Here, right? This AVG, ATN, AVN, ATG you have to find out from the. We have to find out. For that we have formulas, right? Okay, anyhow, here now LT we have to find out first. For that W minus W1, right? That is 100 minus 60, whatever I told, that is 40 mm, the remaining mm in the diagram. LV is LT plus P into 4. LT plus P into 4. P is nothing but pitch distance given in the question, that is 50. Why into 4? Because there will be a 4 bolts given in the question, right? 5 bolts. 5 bolts means 4 pitches will come. So given in the question, you can check it. Diagram you can check. I'll not go with that. Better, if you are seeing this video, have a PDF of that also with you, a Xerox of notes. I'll share the PDF. That PDF also you have to be separate and video have to see. Then you can go with the any pages. Right. If I go with the diagram also, I'll go here. You can see 40, that is W1, and the P distance, right? We want P. There will be 4 P values. 1, 2, 3, 4 P values. Means 5 volts are there. Means 4 P will come. 1, 2, 3, 4 in between the volts. So P into 4 plus LT we have to multiply, right? That what add. That what we calculated here. That is LT plus P into 4, that is 40 plus 50 into 4, that is 240 mm. LT we got it, right? This is written for just for you to refer how we got that and all. This is not need to write. For understanding I written these sentences. Now we have to find out AVG values. AVG is LV into T. LV is 240 into T, that is 8 mm. Then AVN is LV minus 4.4 and half D naught. Why 4 and half D naught? Because 5 volts are given. 5 volts means 4 and half you have to give, then half you have to give here in the ATN value. Here 4 and half D naught into T, if D naught is 22 and you got this value, then ATG is equal to LT into T. Here you can remember AVG is LV into T, ATG is LT into T. AVN means we have to minus from LV 4.5 D naught, and ATN means you have to minus from LT minus half D naught. This you remember. Okay, D naught is 22, LT is whatever 40 mm. Got the all the 4 values of A values, AVG, AVN, ATG, ATN. These 4 formulas should be remembered. That is not there in the core book also. Right, now to substitute all the values in TB1 and TB2 formulas. I'll not explain. Fy is 250 always, and gamma m0 and ml. M0 is 1.1, ml is 1.25. We'll get TB1, that is in terms of Newton, we'll get convert into kilonewton, Newton convert into kilonewton. So whatever the final design tensile capacity, how we are right, you have to go with the first step, that is a TDG value, or you can say is as gross section yielding, where we got one TDG value, right? This value. Same way we got TDN value finally, that is 343. This second step last we got values. In the third step we got 2 values, right? One is 320 and is 264. So out of these 4 values, which is the least value, that is 264, the least value out of these 4 values, that value has taken as design tensile capacity. Okay, finally I have to conclude with this point. Okay, I'll go with the second problem. This formula is this here, using single angle they given, and this is second problem, little bit different of plates they given here. I think here some different is there. Whatever the area we have to find out. Here what is the difference? Okay, in the first problem they given find out the determine the tensile capacity. Here determine the tensile capacity of the joint, right? Here in the second question, see, first itself they given design, right? They didn't give an angle, we have to design the angle. In the first question they given angle of 100 into 100 into 8 mm. Here they didn't give an angle, that is they told to design angle using these loads. Factor load they given 100 kilonewton, then 16 mm dia, length of member is 2 meter, ultimate stress is 410, that is Fu, yield stress is Fy 250. So given data, T is 100 kilonewton, D is 16 mm, L is length 2 meter, then 410 and Fy is 250. So to find whatever the calculation you have to do, that is how to design the angle. For that step is different, right? Now first we'll go with the page number 33 of code book, where TDN is equal to alpha AN FU by gamma ml. That formula is there in the page number 33. I'll show here, page number 33. This is yield stress. Now here we have TDN formula 0.9 AN FU by gamma ml. TDN is equal to 0.9 AN FU by gamma ml. This is for plates, right? For design say angle. First step is this formula you have to not known. TDN gamma ml by gamma alpha fu, where alpha is 0.8. Remember, alpha is 0.8. It is always 0.8 constant value. So an in this you have to find out an value. Out from this formula we have to find out an value. You have to rearrange the equation and you have to get an values. TDN is whatever the 100 kilonewton given, right? T value that you have to multiply with 10 raised to 3 to convert into Newton. Gamma ml is 1.25, alpha is 0.8 and F is 410. You will get an value as in terms of mm square. You have to increase 25%, that is 1.25 into 381, you will get 476.25. Increase 25%. There is a one calculation of to find AG. AG value we are doing this one. First step is 1, and then another AG value what is there, that is by using the formula of TDG. Here above the formula you can see, right? First we use this formula, now we have to use this formula AGFY by gamma m naught, where you will get the AG values. Rearrange the equation. TDG is 100 into 10 to the 3 to convert Newton, then m naught is 1.1 and F is 250, you will get 440. So we got 476 and 450. So which is the maximum value you have to take, that is 476.25 mm square. Next step is to selection of the angle. Here written smallly, you can understand. Wait, right here star and all are given. From steel table page number 2, select the section, right? So steel table we have to open. From the steel table page number 2, the value is AG value is 476. We need more than that values, right? More than 476.25 we need. So for that we have to go with the page number 2. I'll show here page number 7. We need more than 476.25. so here you can see this is 479, right? This is 568. So these are the values in terms of centimeter square. They given as 1.12. if we take point out and read like 386 to 34, that is in terms of mm square. So we need 476.25, more than 476.25. so we having here 479 and 568, right? Will be go with the 568. Why? Because don't go just above the values, go with the more above values, that is 568. Can go with any more values, right? So 568 will go, that is ISA 15 to 15 to 6 mm, right? That is 568. So I selected that only, ISA 15 to 15 to 6 mm, where the values of all the 4 properties and all you have to note down of ISA 15 to 15 to 6. Okay, FUB is 400 given in the question. Then you have to go with the design of bolted connection is the next step, where in the second module we got it, right? Shear capacity and bear capacity. The same step you have to follow here. A and B value, that is 0.78 pi by 4d square, they will get 0.57. Then go with the shear capacity, page number 75. VDSP you have to find out. This formula and I'll explain in the module 2. If you have doubt either, you can go with the module 2 once and come here. So this value of substitute, then you'll get VDSP 29. Then same way bear capacity, page number 75 of the cold book. Then VDP value, then KB values I have to find out which is the least value, you have to take it down, and ENP values formulas. Then you will get the value of VNPV, that is 37. So bolt value is least of the both two values, that is 29. So you'll get the number of bolts. Load is given in 100 divided by volt value 29, you will get 4 number of bolts. This and all explained in the second module. Same step you have to continue here. Then one more step is there, one check is there. You have to check against yielding, check for rupture and check for block shear you have to do, but it will make lengthy. At least you will get 80% of the marks if you do. So check against yielding you have to do it. That is TDG formula. Initially we applied AGFY by gamma m naught. AG is whatever, right now AG value is whatever 15 to 56 we got it now in the steel table. That AG value 568 into 250 is Fy divided by 1.1. So you will get in terms of Newton, that is in terms of kilonewton 129.09. It is more than given load, that is 100. That's why it is safe, right? I think here written it is enough, because you have to do check for block shear also, check for against rupture also, but it will make lengthy and difficult for you. So after this, if it is enough, you will get 90% of the marks. Okay, anyhow, this is about the module 4. One more problem is there in the module 4, that is plate. In terms of angle, they given plate, right? 150 into 10 mm plate connected to it. You have to find out the strength of the plate. So they given the plate 150 into 10 mm. This diagram is given in the question, shown in figure. These 6 bolts are there. This is 60 mm, and 150 into 10 is plates, and 60 is pitch distance, and E is 30 is the E value, and they given B value as 150 here. You can see here, right? This is B value 150, they given in the bottom. Anyhow, first step is same as in the first problem is calculated now. Same steps we have to follow of tensile capacity. First problem of this module. First you have to go with the tensile strength of the plate. You have to go with the page number 32 TDG value, where AG is 150 into 10, right? Plate is nothing but 150 into 10 and 250, and you will get the value of AG values. Same way, whenever we will go with the strength due to rupture, whenever we will go with the rupture, the formula is different, right? I'll show page number 33 of the code book. Whatever the formula we got for the angle, we go with this formula. For the plates, we have to go with this formula, 0.9 Fu by gamma naught. Simple formulas, right? Page number 32, 33 actually, this is 32, 33.9 Fu by gamma naught. And An value, to find out An value, B minus 2D naught into T. This is the formula, remember. 150 minus 2 into 18 into 10, then you will get N values. Then B value is given in the question, that is 150 mm. Okay, next. Then TDN is, you have to substitute N value, then Fu, then gamma ml. You will get the value of, in terms of Newton, you have to convert into kilonewton. Same way, third step is block shear. The formula is same as question number 1, right? In the 33 page number, strength due to block shear 6.4 is there, where 2 formulas, TDB formulas are there, that you have to note down as TB1 and TB2. Anyhow, before that you have to make a diagram like this. Why I have made diagram like this? There will be 6 bolts, 1 2 3 4 5 6 here together written, and this is 30 mm, this is 60 mm, and this is 30 edge distance and P distance. Here also P edge. So LV is 30 plus 60 into 2. LV means nothing but this distance. 30 plus, sorry, not this distance, that is LT. LV is this distance from here to here, from here to edge of this distance. 60 plus 30 is there, na? 260 plus 30, that is 150 mm, or else given it as B also in the question. Directly you can take it. AVG is equal to 2 into LV into T, right? That is formula. These formulas you have to remember. Same way in the first problem also, I given formulas for angles. Here plates a little bit different is there, you can identify with that formulas. LV is into T is 150 into 10, you will get 3000 AVG. Then 2.5Y, because one row 3 bolts are there, so 2.5 D naught into T, 2100. ATG is LT into T, LT is 60 into 10, that is 600. P into T you can make it. ATN is 6 minus D naught, 1 D naught is there now. Here 2.5 is gone, total 3 bolts, 1 is here. So you will get into 10 is nothing but thickness. Thickness is 10 here because the plate is given it as 150 into 10. So you will get 420 ATN values. These 4 values you have to substitute in the TB1 and TB2 formulas. Here AVG is there, ATN is there, VN, ATG. Carefully substitute, don't make mistake. You will get in terms of kilonewton, Newton, have to convert into in terms of kilonewton. Here also you will get in terms of Newton, convert into kilonewton. So tensile, finally how to calculate the strength capacity. Least of the 4 values got, you will get TDN values. Whatever the least value of out of these 3 steps, this least value you got, that has to be written as tensile capacity. Okay, anyhow, in the module 4 these 3 types of problems will come, so study properly. And very important is first and second problem, right? The angle, first problem is to find out the capacity of the joint. Second problem is to design angle. They will not give the angle directly, they will give the load, we have to find out the angle. A little bit different is there, two steps, two problems. Study first two problems, if possible third problem plates you can go with that, right? Most of the times they will ask with the first two problems itself. So first two problems first study. Okay, all the best.